Hello, I welcome you all for my mathematics session. Today, let me teach you the method of finding the transportation problem. A transportation problem is one in which a company tries to minimize the transportation cost of sending the materials from the units of production to units of sale. Here you see that here this S1, I will not explain the full things. I'll just brief out what are the important informations that I have to give here. So you see that a company has got 3 units of production, S1, S2, S3, and the destinations in the sense that where the outlet is there, outlet in the sense that where they are going to sell their product. It is D1, D2, D3, D4 or the destinations where the company will sell their goods. They are nothing but outputs. That is the sale units. That is the places where they sell the products. Now you see that here S1 is a production unit and it produces 70 units in the sense that it will supply 70 units to its sales unit in the sense where they sell the products. And likewise S2 is a manufacturing unit, S3 is a manufacturing unit. They are otherwise called as origins. And here you see that this D1, D2, D3, D4 are called the what? They are called the sink, or you can call them as destinations. So you see that demand, these are all called the destinations. D1, D2, D3, D4 are called the destinations, and S1, S2, S3 may be called as origins. And S1 is producing 70 units, S2 is producing 55 units, S3 is producing 70 units. So the total production of this, when you add, this will be equal to, it is 195. So the 3 units together put 195 units of production, and the demand for their sales unit are 85 for D1, 35 for D2, 50 for D3 and 45 for this. So if you add, this will come to 215 units. So you see that the requirement for the destinations put together is 215 units, whereas the production is 195 units. Now you see that we call such a problem of transportation as an unbalanced transportation problem, in the sense that, see, sum of supplies is equal to sum of demands. So you call this as your A1, A2, A3. Call this as your B1, B2, B3, B4. A1 plus A2 plus A3 is equal to 195. B1 plus B2 plus B3 is equal to 205. And you see that they are not equal to sigma I, AI is not equal to sigma of BJJ. That is, the sum of the supplies is not equal to sum of the demands. So this is an unbalanced problem. This is an unbalanced problem. This is an unbalanced problem. Now you see that what I am going to do is that now I will just tell you in brief what is that we are going to do in this problem. So you see that S1 it can supply to D1, D2, D3, D4. And what are the elements that are inside this matrix? So you see that S1 to D1, 6. It means that if you transport 1 unit of material from the source S1 to the source D1, you have to spend 6 rupees. I'll repeat again. You have to spend 6 rupees per unit for transportation of the materials or the products from the source S1 to D1. So this is my understanding. Likewise, from S3, if you send the materials to D2, you have to incur an expenditure of 12 rupees per unit. Now, you see that S1 can send to D1 or D2 or D3 or D4. Likewise, S2 can send to any of this. The question is how effectively or cleverly you will send the materials, products from S1 to S2, S3 to D1, D2, D3 and D4 in such a way how cleverly you will send so that the overall transportation cost is kept minimum. So transportation cost is a minimization problem, and you see that how it is given. See the that is the transportation problem is given by TP is given by, it's a linear programming problem, that is it is an LPP. It is an LPP. It is given by Z is equal to min of Z. Min of Z is equal to sigma I varying from 1 to m and sigma j varying from 1 to n. It is Cij into Xij, and sigma Xij I varying from 1 to m is equal to Ai, and it is sigma of Xij is equal to your and this one, see, sigma j is equal to 1 to n, Xij is equal to your here sigma of, it is a bj, I'll put it as bj. So you see that if you add up here, how you should understand is, see, it is like this. I'll write it here. Xi1, Xi2, Xi3 plus dot 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 Xi, it is Xin is equal to Ai for I is equal to 1 to m. That means Xi here, you see that if you take the first row X11, that is sum of the supplies from ith row to the destinations must be equal to the supply or the capacity at the source I. What I mean here is that, see, take for example this S1, this is a source S1. You can supply to D1, D2, D3 or D4 in any way you want, but the sum of the supplies that you do to the destinations cannot be more than the capacity of the source. Can you catch what I am telling you? So that is what I have written here. Xi1 plus Xi2, that means ith row. First I refers to the row, first suffix refers to the source, second suffix refers to the destinations. You take for example this ith row and you supply it to the destinations. You can supply it to the destination you need not, and you need not supply to a destination also. That means you can supply to a destination j, or you need not supply. Your supply can be 0 also. Or you can supply to all destinations. You do whatever you want, but the sum of the supplies that you have made must be equal to what? The capacity at that source. That is what. So this is what I have written here. So this is, in general, this is written as, say it is I is equal to 1 TM. It is I is equal to 1 TM. And this we will write it as I is equal to 1 to m. It is 1 to n. It is I is equal to 1 to n. X I j is equal to, it is xij is equal to. Similarly, you take this destination. This destination 1 can get the products from S1 or S2 or S3. It can get from any either S1, S2 or S1, S3 or all the three, but in whatever way it gets the products for sale from the sources, the sum of the supplies it gets cannot exceed the demand it has. What I mean is that, see here the simple words is that S1 can supply, S2 can supply, S3 can supply, but the total number of supply cannot be more than the demand of this D1, which is 85 units. That is the meaning of that. So this we put it as, see here it is like that. I will put it like this. X1, see it is your X, see it is X1j plus X2j plus X3j plus Xmj is equal to your Bj. J is varying from 1 to n. Now you just see that I take the, see for example, you take the jth destination. You take the jth destination. So what happens is, 1 can supply to jth destination, 2 can supply to jth destination, 3 can supply to jth destination. Likewise, mth source can also supply to jth destination. But you must know that the sum of all this must be equal to the Bj, which is nothing but the supply, that is the demand of that particular destination. I will repeat this. See here, I will put it in this way. See, it is like this. There is a jth destination like this. Let us suppose that it is your jth destination. And you see that here S1 can supply, S2 can supply, S3 can supply, but they can supply. That means what? X1j, X2j, X3j, like that it can go up to what? M sources are there. So you see that they can supply in any way, but your demand that you have got here is that your Bj. Are you able to understand? I'll repeat this. So there is a destination Dj. S1 can supply, S2 can supply, S3 can supply, and likewise mth destination can also supply. Yet, or some of them need not supply also, but in whatever way the supplies are made to the destination Dj, the sum of these, all these, X1j, I have written, see, X1j plus X2j plus X3j plus X4j up to Xmj is equal to Bj only. Are you able to understand? So this is true for what? Jth, but it is true for all destinations. So this we write it as, see here it is written as I is equal to 1 to m. Okay, it is X, it is Xij is equal to Bj, and j is equal to 1 to n. Now you just see that here you put I is equal to, see, you take this X1j plus X2j plus X3j up to Bj. Suppose if you take j is equal to 1, you will get the first row. If we take first column, if we take j is equal to 2, second column. If we take j is equal to 3, third column. Like that, you find that these are the columns. These are the columns, they refer to the destinations, and that here in this small problem you understand that S1 can supply to D4, S2 can supply to D4, S3 can supply to D4, but it can supply or it need not supply also. But in whatever way the supplies come from S1, S2, S3 to D4, you add all the supplies, it cannot exceed the 45 units. It has to be equal to 45 units. So this is called as transfer, and this Xij's are called the Xij's are called the allocations. See these, see Xij called allocation from ith source to jth destination. So you see that by Xij I mean it is called the allocation, ALLO. I'll write this. This is an important word that you must understand. So this is allocation from the source, ith source to jth destination. And what is that Cij? Cij is unit cost of transportation from ith source to jth destination. So this is what I mean by this. So what is your Cij? Cij is nothing but the unit cost of transfer. That means the cost of transporting 1 unit of material from ith source to jth destination. That is what I mean by what? Unit cost of transportation. And in the same way, Xij means the allocations from the ith route to ith source to jth destination. For example, you see that here the cost of transfer 1 this is C11, this is C23, because the cost of transportation from the source 2 to destination 3 is 2 rupees per unit. See, that is what we need. Now our question is, in what better way the sources will send the materials to the destinations so that the overall transportation cost, see, this is kept minimum. See, Cij and Xij, in all possibles you try and transport the materials from the what? The sources to the destinations, but you must know that the overall cost must be minimum. This is linear, this is a linear, and this is minimization problem subject to the constraints. What is that constraint? It is, so Ij is equal to 1, Xij is equal to I for I is equal to 1 to m, and the I is equal to 1 to m of Xij is equal to Bj for j is equal to 1, and these Xij's are greater than, see, it is equal to 0 or Xij is equal to, it is greater than 0, see, greater than 0. That means what? The allocations, it can be 0 or a positive number, it cannot be a negative quantity. They are called feasible solutions. Xij's are called what? Non-negative, they are called the feasible solutions. And therefore here the transportation problem is given by minimization of Z. This is a linear programming problem. I have written here linear programming problem. This is minimization of Z. I is equal to 1 to m, this refers to the row, and j is equal to 1 to n, this refers to the destinations, and this is source and destination, Cij into Xij. Xij refers to the allocation from the ith source to jth destination, and Cij refers to the unit cost of transportation from ith source to jth destination, and this can be minimized subject to the conditions that j is equal to 1 to n of n, Xij is equal to I. The meaning of this is that from ith source you can send materials to what? That is to the destinations 1 or 2 or 3 or 4 up to n, but the sum of the supplies cannot exceed the capacity at that source AI, at the source SI. And likewise another condition is that the sigma I is equal to 1 Tm of Xij is equal to Bj, and this means that x1j plus x2j plus x3j up to xmj is equal to Bj. The meaning of this is that jth destination can get materials from source 1 or source 2 or source 3 or from all. But if you add up all the supplies from the sources, then it must add up to the maximum equal to, it must be equal to the demand at the destination j, and that these xij's allocations, they are called allocations from ith source to jth destination. For all I and j, it has to be either equal to 0 or can be a positive number only. It cannot be negative, and therefore this is a linear programming problem. And now here we have to solve this in the sense that you try to find the allocations in such a way that the overall cost is kept minimum. There are various, we have got 3 methods of doing it: northwest corner method, and you have got least cost method, and Vogel's approximation method. And Vogel's approximation method is most applicable because it is the method which gives us the minimum. Compared to the other 2 methods, you will get the minimum cost of transportation. So we will apply that and get, but know that even that cannot be taken as the minimum cost. We use another method called the Modi method, by which we will be able to get the optimal transportation cost. Optimal transportation cost in the sense that the least cost possible, I mean the minimum cost. So I will teach you the method of doing it. So you see that now, so this is, I have brought out everything very briefly, and that you must know that first of all you must check whether the given transportation problem is a balanced one. A transportation problem is said to be balanced only when the sum of the supplies is equal to sum of the demands. Then only you can proceed. Otherwise you have to balance and then start doing the problem. I'll teach you first the method of finding the using the Vogel's approximation method, how to find the solution. After then I will teach you in another class how it has to be optimized further. So in this class I will teach you only of how to use the Vogel's approximation method to get the solution. So we will do that. So here you see that so I will see carefully, watch how I do this problem, and you see that this problem is not a balanced one. I have already written that this is not a balanced problem. So you see that where the surplus comes, here you see that the demand side, the surplus is there, a deficit there only in the source, so you have to balance that first. So I'll write here S1, S2, S3, and this is D1, D2, D3, D4, 6, 1, 9, 3, 11, 5, 2, 8, and it is 10, 12, 4, 7. And you see that this is supply, it is 70, and it is 55, and it is 70, and it is demand. Demand is 85, and it is 35, it is 50, and it is 45. And you see that it is 195. So there is a deficit on the source side. So I will try add a fictitious S. This is called a fictitious S4. The unit cost of transportation is everywhere taken to be 0. And what is the deficit that you get? 20. So you see that now it is balanced. Now you see that I have balanced it by introducing a fictitious source S4 with 0 cost of transportation from the source to the destinations, and the capacity is 20. Thereby I am able to balance this. Now I can go ahead with the problem using the Vogel's approximation method. Let us use, I'll write here, let us use Vogel's approximation method to find basic feasible solution, BFS. See, know that it has got a lot of meaning. Basic, it's basic. Feasible means, I told you, feasible means what? Allocations. That is to find allocations, proper allocations. That is, in these transportation problems, you will try and find out the allocations. So here you see that basic allocations cannot be negative. They have to be either 0 or a positive quantity, and that is why we say that what? It is a basic feasible solution. Are you able to understand? And another thing that you must know is, see here, you see that how many rows are there? Now you see that I have added this row, and because it has to be balanced. It was an unbalanced one, therefore this is balanced, and thereby I am able to get a matrix. What is that? The 4x4 matrix. You see that how many rows? 1, 2, 3, 4. How many columns? 4. So it's a 4x4 matrix. It is a 4x4 matrix, and number of solutions is equal to m plus n minus 1. That is 4 plus 4 minus 1. That must be what? Solution. So you must have number of allocations. Number of allocations must be what? 7. And if it is less than 7, it is a problem of degeneration. Can you understand? It's a degenerate problem. That means what? You have to solve it in a different way. That I will teach you when the situation comes. Now you must know that what is the meaning of for finding a solution? Finding of a solution means finding Xij's. See, so by solution we mean find Xij's. By solution we mean the Xij's. The Xij's must be found in such a way that they minimize the overall cost. That is the meaning of that. So you see that if the number of rows are m and number of columns are n, then the number of possible feasible solutions are m plus n minus 1, and that if it is less than that, it is called a problem of degeneration. And in this particular problem, 4 rows and 4 columns are there, and therefore you must have 7 solutions. If you have less than 7, it is called a problem of degeneration, and it has to be solved in a different way. That I will tell you in the coming classes. So we will try to solve this. Now I will use this Vogel's approximation method or penalty method. See, this is another way called as what? Vogel's approximation or penalty method. PNAL. It is also called as what? Penalty method. It is also called as penalty method. Now let us try solve this. Now I will rub off everything. Let there not be any confusions. I told you that because of these reasons it is unbalanced. So this is an unbalanced problem. I have balanced the problem. Now I am going to solve this. That is, in the sense, try to get the solution. See, what that you have to do is, say, I will explain. Find the penalty. See, you have to penalty in the sense, what is the least cost here? 0. What is the next least cost here? 6. What is the difference between this? It is called 6. So this is called your penalty. Penalty for this column. This is 1, 0, next is 1, so the difference is 1. So this is my penalty. This is 0, next is 2, next least cost is 2, so the penalty is 2. This is 0, next cost is 3, so your penalty is 3. So you see that this is your penalty. And let us come to this. Now come to the rows. This is your smallest cost, next smallest is 3, so the difference is 2. So these are called penalties. These are called penalties. And here the least cost is 2, next is 5, the difference is 3. Here the least is 4, next is 7, so it is 3. Here it is everywhere it is 0, so you see that the least penalty is 0. So what is that I have done here? I have found the penalty for each row and column. What is that I have done? I have found the penalty for each row and column, which is nothing but the difference between the least cost and the immediate next least cost. So you see that 0, 6, 6. Now after then choose the maximum of the penalties, and see, you choose the maximum of penalties 6. So you are choosing the first row. Go through this row, go through this maximum penalty row or column and select the minimum cost. Now what is that? You go, this is your 6 is the maximum penalty. Go through this column and find out where do you have this minimum least cost. You see that this is your cost. So this 0 is your cost. For this cost you allocate the minimum of 20 and 85. Are you able to understand? So you choose this. See, I'll repeat this. You find out the penalty, choose the maximum penalty, go through that maximum penalty row or column and find out the least cost and allocate to that cell. This is a cell. This is what, which cell it is? It is 4th row, first column. So your 4th row, first column has been selected because it is the least cost cell. To this cell you allocate the minimum of 20 and 55. That means what? Minimum of 20, 20, 85. That means you go to this cell. Now you see that this is 20 and this is 85. So this is your 20 is the least cost. Allocate to that. Now this 20 has been given. So no longer this is in use. So you round it off. And simultaneously you reduce this by what? 65. So you see that 85, 20 is the supply available, 85 is required. So for this D1 we are able to give 20 units, therefore it requires now only 65 units. So you round it off to 65 units and now you see that this is closed. This is closed. So with respect to this penalty I have made the allocation. Now you see that this will remain the same, 3, 3, 2. So you see that here it is 3, 4, 3. And coming to this, so this is over. Now go for repeat that process. In the sense, now you go find out, now you find the penalty again. What is the penalty now here? The penalty is 6, nextly is this 10, so it is 4. Here 1 is the least cost, least cost, next is 5, so it is 4. Now here it is 2 and the next is 4, it is 2. Here it is 3, next is 7, so it is 4. And here this will remain the same. See, here 1, 2, so this will remain the same. So this is the least cost. Now you choose the maximum penalty between the rows and columns. Now you see that you have got 4 here, 4 here, 4 here, maximum. So without loss of generality, you can choose any other 4s. Let me take this 4. Now go along this. Now move along this column, come to the least cost. Where is your least cost here? 6. Now allocate to this 6 the minimum of 70 and 65. What is the minimum of 70 and 65? So it is 65. So 65 is fully given. So you see that you're going to round off this. That means what? This D1 is fully satisfied. Previously it got 20, now it has got 65. So 85 units it has received from the sources. So there is nothing left for it to be supplied. So what is that? You have given 65. So what is that left here now? It is 5. So you see that I am here. See, I am able to make the second allocation. I am able to make the second allocation. Now you see that for this, so with respect to this is over, this is over. Now that this column is closed, just like this column is closed. Now this will remain the same. You just see that 4, 2, 4. Now you make a change here. Now go to the rows here. The least is 1, the next least is 3, so it is 2. The least is 2, next least is 5, so it is 3. The least is 4, and here also it is 3. Now you see that here again 4, 4. Here 4 happens to be the maximum. Choose the maximum of all the penalties and move along this column. Come to the minimum. Where is your minimum here? 1. Now allocate to this what is that? Here it is 5. Here it is 35. It is the supply remaining is 35. Demand is 35. Now between these two, what is that minimum? It is 5. So it is 5. Now round off this. Once this is given, you see that S1 has given whole of its 70 to the destination. So it is over. Nowhere, it will not have anything at all. And simultaneously, what is that you will do now? Reduce this by 5. So it is 30. So the third allocation is done. Again, now, so you go for, again what? You go for the finding the penalty. Now you see that this will remain the same. This is 3 and this is 3. And coming to this is over. And come to this is 5 and 12. So the penalty is 7. Come to this, the penalty is 2. Come to this, the penalty is 1. Now you compare which is the maximum here. Nothing. 3, 3, 7, 2, 1. Which is your maximum here? Your 7 is the maximum. Go along this column. Come to this 5. Compare this 30 and 55. Which is the minimum of these two? It is 30. So round off this like this. The meaning is that the D2 is completely satisfied. So you see that this 30 if you give, the remaining is 25. So you see that this column is closed. This column is closed. Now this will remain the same. And you see that this row, with respect to this row, we have done the problem. Now come to this. This is over, and you see that this is also over. Now come to this. This is 2 and 8, and it is 6. And this is 4 and 7. It is penalty is 3. Now which is your maximum here? 6. Go along this row. Come to the, see these are all over. Here 2 and 8 are remaining. 2 is the minimum. So for this minimum, compare 50 and 25. Which is the minimum of these two? So it is 25. So when you give this 25, you see that this is completely over. So this is completely over means you close this row. You close this row like this. Yeah. And simultaneously reduce this by what? 25. Now you see that here this is over and you are left only with this 1. And here you see that this is over and this is over, this is over. What is this? This is 4 and this is 7. And which is the maximum penalty here? 7 is the maximum penalty. Go over this. You will find that what? 7 is the go along this. So 7 is the minimum here. Now 70 and 45. Which is the minimum of these two? 45. So what will be the balance here? 25. Now you see that yes. So this you are giving 70, 45 you are giving. So you are giving 45. So this column is over. Completely over. And this is 25. And this is closed. This is closed. This is closed. Now you can see that 25 remaining and 25. Supply side, demand side 25 and supply 25. So this is the place that you get. So you see that we are able to allocate the allocate from the sources to the destinations using Vogel's approximation method. I'll just make a very brief. I'll briefly tell you what I have done here. Given a problem of this type, you try to find out the penalties. Penalties in the sense that you find out what is the least cost and the next least cost, find the difference, that is called your penalty. Find the penalty for every row and every column. After completing it, then you choose the maximum of the penalties. It may be a row or column. If it is a row or column, go along that row and column and find out which is the minimum cost cell, and to that minimum cost cell you supply, your allocation must be minimum of the supply and demand with respect to the columns and rows that you have chosen. See, for example, you see that, so this is what I have done. So this is, now after completing this, what you have to do is rewrite this. So I'll write here, so Vogel's approximation method. So I'll put it here, D1, S2, S3, D1, D2, D3, D1, D2, D3, D4, S1, S2, S3, S4, and this is 6, 1, 9, 3, and it is 11, 5, 2, 8, 10, 12, 4, 7, 0, 0, 0, 0. And what is this? 85, 35, 50, 45, this is 70, this is 55, this is 70, and this is 20. Now you see that one, it's a balanced one. Now see here, the first, go to the first cell. This is your first cell. You have made an allocation. So how much allocation you have done here? 65. Then first see, this is 1, 1 means first row, first column, cell. Then the second 1, 2. For 1, 2 you have given 5. So you have allocated this 5 and nowhere. Come to the second row. For the second cell 2, 2 you have allocated 30. And 2, 3 second row, third column you have allocated 25. Then no, after that let us come to the third row. Third column 25. Third row, fourth column 45. This is cell 3, 3. This is cell 3, 4. Then come to the last one. So you see that your allocation is 20. After doing this, you have to see whether the constraints are satisfied. What is that constraint? Rim conditions. We call them as rim conditions. Rim conditions are nothing but the sum of the supplies from the sources to the destinations must be equal to the capacity at that source. You know what does it mean? See here, you see that this is your supply. This is supply and this is your demand. And you see that S1 has supplied to D1 and D2, that's all. Now how much has it supplied? 65 plus 5, that is equal to 70. That means source 1 has supplied materials or its products to only 2 destinations, and that the sum of the supplies is equal to its availability. How much is the availability? 70. So rim condition is satisfied. Okay, come to the second one. See, the second source has given to the destination 2 and destination 3. To destination 2, 30 units. To destination 3, 25 units. Now add them, 55 units. Yes, it has given, it has 55 units. It has parted with 55 units. So rim condition satisfied. Likewise, S3, 25 plus 45 is 70. S4 is 20, that is also. Likewise, for demand, that is, the destinations can get the supplies from any number of sources, but the sum of the supplies must be equal to its requirement. What is its requirement? Now D1 requires only 85. Now S1 has supplied and S4 has supplied. S1 has given 65 units, S4 has given 20 units. So 65 plus 20 is 85 units. So rim condition is satisfied. Come to this D2, it is 5 plus 30, 35. So it got 5 units from S1, 30 units from S2, and the sum of the supplies is 35 and its requirement is also 35. So there again the rim condition is satisfied. And here 25 plus 25, 50. Rim condition satisfied. So 45. So you see that my problem is perfectly correct because I am able to the solutions. Now these are all called solutions. I will write here. See here, I'll write here, I'll rub off this. See the solution. So what is the solution that you write? The solution to the problem is the BFS, basic feasible solution, is the BFS. That is, see, this is your X11 cell. X11. What is your X11? 65 allocation. Xij allocation from I to J. This is what I mean. So this is first source to first destination. And what is your X12? 5 units. 5 units. Then X2, 2. From source 2 to destination 2, 30. Then X2, 3. Source 2 to destination 3, 25 units. Then X3, 3. Source 3 to destination 3, 25 units. Then X3, 4. It is source 3 to destination 4. It is 45. And X4, 1 is equal to 20. So this is my solution. Actually speaking, this is my solution. And this solution, it gives, now what is the basic feasible solution? The initial costs. Now you must write this as, therefore, yes, the initial costs. Therefore, initial cost of transportation is, see, allocation, see, allocation cost per unit and cost per unit and total cost. See, I'll write here. See, X11, allocation X11 and cost per unit is, see, X11 is equal to 65. It is, cost per unit is 6. So, $390. So you can call it as rupees also. You can give units of rupees. units of rupees. Then x12 is equal to 5, 1, so it is 5. Then x22 is equal to 30 and it is 5, it is 150. Then x23 is equal to 25 and it is 2, it is 50. Then x33, what's that? X33, 25, it is 4, it is 100. x34 is equal to 45 and its cost is 7 rupees. See, this is the cost. $315. Then x41 is equal to 20, is 0 cost, it is 0. Overall cost is equal to 5. Yes, 5 plus 5 is 10, 10, 20, 21. 2 plus 3 is 5, 6, 7, 7 plus 3 is 10. Now what is the total cost that you get here? Just 5, 150, this is 50, 100, 315, 0, 5 plus 5 is 10, 2, then 12, 12 plus 9 is 21, 5, 6, 7 plus 3 is. So what is the total overall cost? So the overall cost for this is that this is 1010. Now this is Vogel's approximation method, gives you the comparatively speaking with the northwest corner method. There are two other methods, north-west corner method. Northwest corner method. Then least cost method. Least cost method. LCM. Least cost method. So when compared to this is Vogel's VAM. This is VAM. Vogel's approximation method. So compared to this LCM and NWCM, Vogel's approximation method gives you comparatively a lesser amount. Minimum. This is the method of finding the cost of transportation. Basic, I have written here, see, basic feasible solution, and this is my basic feasible solution, and the initial cost is 10. Now we have to see whether it can be reduced further, and the further, that is, we do this by using another method. Okay, now that method will be taught. So I will teach you the other method of finding the least cost, that is lesser than this cost of using Vogel's approximation method in my next class. So this is how I do this Vogel's approximation method. I will tell you in brief something about this least cost method in the next class, and then solve this problem for what? The optimal cost. Okay, thank you.